Brian Silverman and I are going to ask you to come with us on a little bit of a journey. We're going back in history and then we'll come forward and so on. We're going to talk about 20 things to do with a computer, thanks to three significant people. Seymour Papert, pictured here, Marvin Minsky, and Alan Kay. And here's a picture of, you can see, there they are, Seymour and Marvin and Alan, and they surround, this is when they were Disney fellows. And so there's a Disney person there, and Danny Hillis, who had been a student with Marvin and Seymour.
Cynthia.
Here they are costumed in the Disney world. Now, this talk, the title for it is based on a paper that Seymour and I wrote over 50 years ago. And the paper was based on work we did with children using when we were first developing the programming language Logo designed for children. The first year Seymour and I team taught, we didn't have any graphics. In the second year, we had turtles, both floor turtles and display turtles. And the paper is based on what we did and what we would have liked to have been able to do. And so this talk is also about what we did, what was done, and things we would like to see happen. Brian, so I go way back 50 years. Brian joined the Logo community when he was an undergraduate at MIT and was a classmate with Danny Hillis and Margaret Minsky and a whole crew of talented Logo folks. And Brian later became a lead designer for various versions of Logo. He could also introduce himself. Maybe I should let him. He with Danny and a couple of other people built a tic-tac-toe machine, which is on exhibit in some museum or other. And he's currently one of the major characters behind turtle art. Brian, do you want to introduce yourself more?
Sure. Can you hear me?
Yes.
Okay. It's funny that when you say you present me as one of the newcomers, but I guess next year will be the 50th anniversary of when I got to MIT. So if it's a newcomer, it's half a century. I guess you were there 10 years older, 10 years earlier. So that actually may be a little bit longer. I was an undergrad at MIT and I fell into the Logo gang, and primarily first as a student. It's just one of the things that was nice about the lab is they didn't shoo you away even if you didn't belong there. So in those days, it was a chance to actually interact with the computer and write simple programs and things. And as Cynthia was starting to say, from that, after spending a couple of years building gadgets for blind people, Cynthia and I and Marvin and Seymour and a couple of other people started Logo Computer Systems. And with Logo Computer System, we got out lots and lots and lots of different versions of Logo, because the computer companies at the time, given that it's vintage computer fair, you probably know that in the early 80s, everybody else was making computers. We ended up doing versions of Logo for maybe a dozen different systems. Computer fair, you probably know that in the early 80s, everybody there's a horrible echo in this. We ended up doing versions of Logo for maybe a dozen. But Cynthia, do you want to continue? You probably know that in the early 80s,
yes. I want to, now that you've met them,
Cynthia, do you want to continue?
Yes, can you hear me? I'm continuing. Here is Alan Kay. Now that you've met
some of the greats in thinking about powerful ideas. We lost Marvin. One of his favorite sayings was, "You don't understand something if you only understand it one way."
Okay.
We lost Jerome Bruner, some of the greats, made it to 100, and he was still vital. Said any subject can be taught in anyone in an intellectually honest form if we heed their level of development. That is something that Marvin believed, and that's something that Seymour believed. And we lost Seymour, who had a wide variety. I picked one that I was sure was going to be used already, and it was, that is a reflection on the difference between learning something in a class and learning something as part of a culture. I'll come back to that towards the end. Marvin also liked to say that school is the best thing ever invented to keep you from thinking about something important for more than a few minutes.
We wanted to create a programming language for children. And this is Seymour and I in 1968, working with seventh graders at a school in Lexington, Massachusetts. And this is an example of one of the most interesting programming projects they worked on, a sentence generator. And their first, this is, if you read Mindstorm, Seymour's book, or some other things, you will hear either Seymour or me quoting one of the young people saying, "Oh, that's why they call them nouns and verbs, because the first sentences they generated were nonsense. They mixed nouns and verbs and adjectives. They didn't think of categories." And so this is an example. Didn't think of categories. And then the next, so this is an example. Whoops, we're going, I'm having a little difficulty there. Create constructionist activities, making sense by making things. And as you can see, this is in 1970-71, when we had a display turtle. And that's where these young people are talking. It had animation and graphics. Brian, do you want to say something about this?
No, it's again is the display in that actually predated their memory being cheap enough to have bitmap displays. So that was a vector display that was custom built by a then graduate student, now MIT professor named Hal Abelson, where Cynthia, this was before I got there, so maybe getting the details wrong. It was basically
Hal Abelson, the person who is behind App Inventor, was the programmer for the first turtle graphics that was portable.
It was a Data General Nova, and back in those days, clearly this is way before personal computers. You could tell that the terminal has, big modem coupler on it, because all of this was connected to a time-sharing computer back at, Cynthia, was BBN in those days?
No, this was MIT. This was the PDP-10 at MIT. Earlier, we used the PDP-1 at Bolt, Brannigan, Newman.
But what you see on the screen is the early days of computer graphics.
Of course, can I tell them the funny story? Typical Seymour, that he needed these things, and he was in the applied math department, and the supernova was just sitting idly, not in use, and so was a monitor. So he borrowed it for this project. And it was several years later that they found where the computer had disappeared to. How was that?
Sure. It's worth remarking the constructionist is a word that Seymour made up as a play on Piaget's constructivist, where Piaget was saying that kids learn things by making mental models, and Seymour figured that in addition to be making models, you could be making stuff as a good way to be learning.
So here is making playful learning environments. And here you can see our first floor turtles. The yellow turtle was a canister that was purchased in the in a whatever you call a scrapyard place. And
it was Taunton military surplus. It wasn't just scrap. It was, you know, all of these organizations that had contracts with the military when they would give their used equipment there. So you'd go to a place and it would have all sorts of amazing things. You know, there was a different day story for a different day where Marvin and Danny Hillis ended up picking up a radiation detector that was a spare for the Apollo mission that went to the moon. And NASA eventually wanted it back, and that led to all sorts of crazy.
Well, and Marvin and his AI lab students and staff made a monthly trip to Taunton to this DOD junkyard. I call it a junkyard, but where they would buy, they didn't have to buy, they just got these pieces. And the other turtle was one that was built in the AI lab. They were both tethered. You can see the long thing, and that's Seymour sitting there, standing there observing the young people. And then here's Seymour.
So at MIT, we've given computers the power.
I'm sorry.
Public school kids vacation. Everybody's coming on vacation.
And we found ways of giving children
I think
the
that's
power
true.
to control the computer. Now they'll put their little students together to make bigger ones.
Wow.
I get into bugs like this, and it'll, when it was doing it in his mind, little turtle, the little triangle thing, was on an angle, so it drew the picture on an angle.
Computer-controlled turtle is made to draw and dance by programs very simple that all children invent them in the first days of the course. Thus, the child acquires a taste for math. It grows and grows as his projects become more original, more complex, and more varied.
I apologize for the sound. I screwed up somehow, but here is the fourth thing: explore turtle geometry as a first visit to Mathland. And these are the kinds of images that children worked on.
Yeah, the idea of Mathland actually is Seymour was fond of saying that what's the best way to learn French? It's just go live in France, because kids who live in France learn French. Wouldn't it be good to have a Mathland where people could go there to learn to speak math? So the early idea of Logo was to use computers to put together a Mathland.
And this is just an example of always we had some kind, beside having music, we also had animation. And
but we pointed since we're talking about the background of this whole talk is the technology. We had animation in the late 60s, early 70s, and then we stopped having animation until it came back in the late 90s, because in the very early days, a lot of this was running on custom hardware. But then when we shifted to commercially available hardware, reasonable computer animation didn't really come out in any good way in the early days. So,
well, I'd like to intercede with that. In at the logo group at MIT, work was done on creating a logo for the Apple. Also, work was done on creating a logo for Texas Instruments TI/99/4. And that was the time that TI machine had a built-in sprite board, originally designed by Danny Hillis for some other reason, but it allowed for multiple turtles. I think there were 28 or 30 altogether for color and for animation. So you could have these turtles flying around on the screen. And I don't know, Brian can talk about the success of the TI machine, but I was thrilled at having that kind of capability finally out of the lab into people's hands. And there was in 1980, Apple, the Logo Computer Systems was founded, and we did a logo, Apple logo. And along with that came a sprite board for Apple logo so that you could have sprites. And that's where I went off in another direction, which I'm not talking about here, but I will mention. In 1982, Alan Kay set me up as director of a research lab for Atari in Cambridge. And that's where we worked on a PlayStation for 5 years from then, where we were going to have vector graphics, animation, music, great drawing capabilities, great text editing, and so on. And we did a lot of wonderful things. But we only had 2.5 years before the lab got closed because Atari got sold. And then Alan became an Apple Fellow. We haven't mentioned Alan, so I'm mentioning him now.
Yeah, no, we should say a little bit more about Alan. Alan, I think he saw his role in all of this as inventing the future. That Cynthia's
let me interrupt you and say, before you get that Alan was a graduate student at Utah in finishing up around 1968. He heard Marvin give a talk, and Marvin mentioned Seymour and logo, and Alan came to visit Seymour and me and the 7th graders at Muzzy Junior High School. And later when we had Turtle Graphics, again, he visited us. And that became a springboard for him for what he wanted in his system at Park.
Right. Park being Xerox Park. And Alan, as a graduate student, conceptualized and made a cardboard mock-up of a computer that looked pretty much the Dynabook. And if you look up the Dynabook, you'll find that it was 1969, looked just like the iPad, only it had a built-in keyboard. And we used to think that, from 1969, when's it going to come? When's it going to come? When's it going to come? And the iPad finally did look like the Dynabook a good 40 some years later. Now, in Alan's work at Xerox Park, what he was trying to do is, he said one of the goals of Xerox Park was to invent the personal computer. And he made a system called the Alto, and the Alto of the documentation, one of the first paragraphs is this paper designs a personal computer. When we say a personal computer, here's what we mean by it. And, then went on is the idea that they did with the Alto was to prototype what things are going to look like years ahead of that. And to a certain extent, that's what Cynthia and their group were trying to do then, is they were trying to be 5 to 10 years ahead of what's actually going to get out there. Alan, by the way, went with the Alto. Some of the things that were invented by that research group at that time were local area networking, drag and drop user interfaces, and object-oriented programming.
And you didn't mention small talk.
And I should have mentioned Smalltalk because Alan, the earliest versions of Smalltalk looked incredibly like somebody had visited Cynthia and Seymour at the lab and went back and said, that's good, but it needs to be object-oriented. So the earliest Smalltalks looked like an object-oriented extension to Logo. Eventually, Smalltalk got an incredible facelift, and it became the Smalltalk that was more obvious later.
And one of the troubles
Whoops. Okay. For me, debugging is the essential ingredient for what happens in a creative learning environment, that it's possible to capitalize on your bugs and sometimes turn them into features, and other times wrestle with them until you can find a path that either excludes that process entirely or makes use of it. And here's Marvin talking about that.
And one of the troubles with education theory until recently is that people had this idea that the best way to learn is to make it a positive experience. Everything should be good. The child should be guided to make very small steps so that they can't make any serious mistakes. And then you learn everything. And when you're all done, you can do the job without thinking because you know exactly what to do. Well, I don't think that kind of learning leads to becoming very good at new problems because you haven't learned enough about bugs. So what we really got to do is to teach children to enjoy being wrong.
Okay, and then here's another thing, which for the time was really an important.
Cynthia, you're going very quickly over a very important point. Is around MIT at that point, programming was debugging, debugging was programming. Jerry Sussman at one point famously said that writing a program is essentially just debugging a blank sheet of paper. And other schools of programming kind of more believed that bugs were to be avoided, where what Marvin is saying and the approach that we always took is bugs are to be embraced and celebrated.
Jerry would still say that today.
Yeah.
So go on.
Go for the next slide now.
Yeah, here it is. That text is not the only interface to a computer. And here shows a child using Radia Perlman's button box. Radia was an undergraduate at MIT at the time and then a postgraduate, and she designed this button box. She was interested in working with 3-year-olds. And so there was a button for forward and so on. And this is children talking to a turtle with a button box.
Oh, truth in advertising, this photo was a photo shoot for the cover picture of the first instance of Mindstorms. And at that point, the button box was already, 5-7 years old?
Yeah. 4 or 5 years, 5 years old.
Yeah.
And but neither thing is attached. And the picture was done by some young people I worked with.
Now, in the idea that recognize the text is not the only interface to the computer. That needed to be said when the paper was written. And I think it needed to be said for like the 30 years following that. These days, you could just say, yeah, of course, text isn't the only interface to a computer. But the idea that there's other modalities that you could use as inputs was kind of ahead of its time. And I think, ironically enough, text may become a more important interface to the computer moving forward.
So, whoop. What did I do? Here are a whole lot of things.
think you
Did I
skipped
skip?
one.
I
Yeah, I think
skipped.
you skipped
I'm
one.
sorry, here. Here we're talking about different kinds of micro worlds. Some of them for children to explore. Some of them are robots and turtles with sensors and music. The top two, this one is about Turtle Stitch, which is the environment I'm especially involved in today. There's a turtle, and through turtle graphics, turtle geometry, I can make these designs and then download the file and load it onto a computerized embroidery machine, which will then print the result. This image here is what Brian is currently very involved in, and that's a design made by Artemis Papert in turtle art. Turtle art. When they first told me about turtle art, I was kind of opposed. Why? Because I and now I embrace it, and that is focusing on just one thing, turtle graphics. It's like now I'm very happy to be involved in turtle graphics on Turtle Stitch. But at the time, I still was coming from a general purpose computing environment. But now with Artemis, her background is she's not only a intellectual of various sorts, she's an artist. And so how do you take simple designs and make them artistic? Brian is wearing a t-shirt that is made from turtle art designs. Is that right, Brian?
Yeah, but I don't know if the people can see it.
Well, they can if you sit up straight.
Well, actually,
Well, it doesn't matter. I'm just making that as a statement. They don't have to see it, but so that's really what I wanted to say about this. Brian, you want to say
Yeah,
something?
no, what I wanted to say is the whole idea of creating micro worlds is what we tried to do over the years, and this is showing some of the various things that came of it. Is a micro world is supposed to be a particular area that you could explore, and Cynthia started by saying that the top left is Turtle Stitch, the top middle is Turtle Art, which if you go to turtleart.org, there's more information about it. The next one over was a robotics kit that we did at the Playful Invention Company. That what we tried to do is well, let me get back to that. The bottom left is the second iteration of the Lego Mindstorms kit. Number 10 was make robots with turtles and sensors, which was something that we set out to do way at the beginning. In joining forces with the Lego company, we actually did it in a way that got very much out to the world. When Lego took on the project from us, they ended up having it have, to our tastes, too much of an engineering field and not enough of a playful field. So we went and made the Pico Cricket kit, which is the thing in the top right, which is also trying to make robots and turtles with sensors, but doing it in a more playful way. The bottom middle, Cynthia, we couldn't remember where that came from, could we?
No. but it's an extension of the do-it-yourself making movement, where
And-
you
And the bottom right is a straight grab from the video that Cynthia showed earlier, where the girls there are making a tune for the music box. That music box was designed by Marvin and was 4-voice polyphonic, back in the early days of computer music.
yes. Oh, whoops. Sorry.
I think you missed one again.
Yeah,
It's even
this
one
one.
further back, I think. Yep.
yeah.
Do you want to speak to this? Back in the early days, Logo was at the MIT Artificial Intelligence Lab, and there was a lot of sloshing back and forth of ideas between AI and education. That what we were doing with trying to think about good educational things for kids fed into some of the thinking about AI and learning. The way they were thinking about AI and learning was feeding into some of the ideas in the Logo Lab. It has to be said that Howard Gardner wrote about 10 years ago, actually it was 20 years ago, that the trouble with artificial intelligence is every 10 years they change their mind and have that label refer to something very different. And it's continuing to be the case, and what we refer to as AI now wasn't what's being referred to as AI then. Back then, AI was very much the MIT AI lab symbolic AI. Now, the next is promote a computer for every child in every country. When this was first written down, it was kind of a pipe dream, but then I guess it was about 20 years ago now. Nicholas Negroponte and others started the One Laptop Per Child project, where you could see the picture on the right. And they made these little green laptops it was originally called the $100 laptop because they had hoped to make it be something that you could buy for $100. They failed at that. They did manage to make and distribute I think it was about 2 million copies of that computer. The important thing that happened with that is up until that point, the computer industry was using Moore's law to make computers more and more powerful. Because of the $100 laptop project, we think they started thinking about making computers cheaper and cheaper. And the $100 OLPC and the $100 laptop project in our heads was one of the motivations for computers becoming inexpensive.
I'd like to talk a little bit about these points also. One of the Marvin and Seymour worked on collaborated together for quite a few years on making machines intelligent. And as they thought about the making machines intelligent, they also drew upon what is it that how children learn. And Seymour, of course, came from spending 5 years wrestling with that question as he was a researcher in Geneva, Switzerland, in Piaget's laboratory prior to joining Marvin. So one of the things that happened when Seymour and I collaborated, we would talk about programming and children, and Logo was originally based on Lisp, the programming language that the AI folks with Marvin and Seymour used. And we talked about, we're going to introduce it later, this little person model, which lent Marvin and Seymour also into thinking about agents, about these little creatures that did little pieces of the work. And they refined it with what Seymour and I talked about was gross activity. And what Marvin and Seymour talked about was much more refined, and what ended up in Society of Mind, a book that started as a collaboration between Marvin and Seymour. But and this is an important point. At some point before the book was done, like around 1980, Seymour decided he couldn't work both full-time on AI and full-time on education, and decided to work full-time on education. And so he didn't complete the work Marvin and he were doing. And that's why he's not a co-author of Society of Mind. Marvin had to reconfigure everything. In the first papers of that Seymour wrote, teaching children, all the early papers, it was always this idea that every child would have a computer. And so when one laptop per child got formed, Marvin and Seymour were enthusiastic sponsors of that activity. In fact, again, we'll point out, Marvin wrote 6 incredibly fabulous education essays, which I edited into a book, which we'll show you later. But these were, I think, important points about the shaping of the logo culture. And the fact, another point that we sometimes don't make is the people that were intimately involved in the early shaping of logo as programmers and so on came out of this MIT AI lab culture. They shared views about how children would learn and how you can teach computers to learn. Anyway, whoops, I'm sorry. Oh, sorry. I don't know. So again, we wanted to give children both physical and mental objects to think with.
The mental objects to think with. So when the book Mindstorms came out, it was children's computers and powerful ideas. And Seymour would grumble in years later that everybody remembered about computers and children, but people weren't really thinking that much about the powerful ideas. And part of the program, the whole idea of logo along the way was to provide both physical and, as importantly, mental objects to think with.
Whoa, sorry. It's my fault. I apologize. So here's where in conversation about programming, programs were procedures, made up of procedures, and they were very much could relate to me or you. There was also this little person model. So there was always an anthropomorphic element in talking about programming. And also it helped to extract bugs from being internally part of you and externally something you could talk about. Do you want to say something about that, Brian?
No, that sounded good.
Okay. So, whoop. So we're coming to it, hopefully. We'd like to be inspired to create new things through papers and books. And the original paper, 20 Things to Do with a Computer, Teaching Children Thinking, was a paper Seymour wrote before this, and it's a fabulous paper. And around the same time after that, he wrote Teaching Children to be Mathematicians versus Teaching Mathematics. And that still stands, just the title itself stands for what we want to do. It's project. Logo was our computer culture was always project-based. It was, you know, there weren't a sequence of steps you had to go through. You could jump around. And of course, Seymour's book, Mindstorms. Here's Mindstorms. There's, you can see the two children playing with the button box was on the cover. And Mindstorms got released again. And this is its current cover. And this, so I screwed up somehow. Anyway, this book, Logo Works, is a collection of programming projects for the Atari computer. That
more precisely for the Atari 800, which the Atari 800 version of Logo was, I guess, for me, a personal favorite, because we had to get an entire programming language in a 16K ROM cartridge and only 16K of RAM memory other than that. And I don't know if anybody in the audience here were fans of the Atari 800. It had one of the most fun graphic system for things that were a computer rather than a game machine in that era. And Cynthia, you were going to say, I'll say it, beat you to it. Logo Works was a terrific book, and its publication was totally simultaneous with Atari collapsing. So the timing couldn't have been worse.
Yeah, it's freely downloadable from my website. And for those of you that are a fan of Brian Harvey, he's one of the editors along with Margaret Minsky, and that got him going on writing computer books for kids. And whoops, here's, sorry, this is Marvin's collection of essays that he originally wrote for one laptop per child. And then the illustrations there were done by Xiao Xiao, and she and I edited this book. So I'm very proud of it. Yes. And it too is freely downloadable as a PDF from the MIT Press bookstore, whatever it's called. And oh, sorry. Well, anyway, this is a new book that Gary Steger edited, and it's got a lot of people essays about the influence the paper 20 Things to Do with a Computer had on their activities. So enjoy that book. And here the recursion line is make up 20 more things. And I want to thank Artemis. Brian and I need to thank Artemis for helping put this together. And here's a list of the 20 things originally. And this is, whoops. Well, anyway, I'm going to stop here and take questions. We've got 10 minutes or so.
Okay. All right. All right. So does anybody have any questions for Cynthia or Brian? Yes, go ahead.
Don't have a Atari 800, can you still invent this on some other equipment?
He says, if you don't have an Atari 800, can you implement this on any other equipment?
Not that I know of, because it really, the graphic system in it specifically took advantage of the features of the Atari 800. which it had if I'm remembering correctly, 4 sprites and hardware collision detection, which I don't think very many other computers did until years later. And actually, I don't know even if we have a copy of the of that cartridge, though. Somebody in the vintage computing world may have that.
All right, I have another question. Yes.
Could we, since some of us, a lot of us have Apple IIs, could we do some of this stuff on the Apple II logo?
Since a lot of us have Apple IIs, can we do any of this on the Apple II version of logo?
The stuff in that book, some of it would work on the Apple II version of logo. And Cynthia, do you remember? Not many of the projects were graphical, and the text projects should work just as well on Apple logo. Do you remember how many of the chapters in the book took advantage of the graphics?
No, but you can modify a lot of them to work on in logos that are currently available, like the Brian Harvey, the Berkeley logo. Berkeley logo only has 1 turtle.
All right, Margaret wants to
a
say
lot of
something.
them micro worlds, and I assume the version of logo that you worked, the versions you worked on beside Atari logo.
Yeah, do we want to let Margaret speak to this, because she
I'll let anybody speak to it.
Yeah, no, because Margaret says that she's actually worked with that stuff quite recently.
Hi, can I jump in on audio?
Absolutely.
Yes, go ahead.
I'm one of the okay. Hello from Shanghai, China. It's nighttime here. I'm just jumping in very quickly to actually honor some work that Cynthia and I just did, adapting one of the programs in MicroWorlds, which is a text-based one. And I just used that with some students. And there's a number of interesting text ones, including the kinds of things that people did, that we all did in those days, like conversation programs. And there's also a logo interpreter written in Logo that's part of that for computer science friends. And the graphics programs take more adaptation. So I just wanted to, but that was just to honor that it is very possible to use that book as direct inspiration.
And then Brian Harvey wrote computer science logo style, 3 volumes.
Yeah.
And those are all, you can use those in various logos. And you can convert a lot of these into other programming environments.
All right, any more questions? Yes.
Since Margaret's in China, my question is, the Chinese kids relate to logo any differently, since they have a very different kind of text script than the Roman characters?
This question is for Margaret. Do the children in China relate differently to logo, since they have a different sort of character sets?
I want to pass that question to others about localization of logo. I myself work at the moment with college students in English, so it's a different set of questions. But there is a lot of very interesting work that Brian, I think, and Cynthia know much more than me about the history of localization in general of logos to different language environments, and especially for younger children, but also for any kind of a logo user. So I'm going to put that back on the table. There are some historians of computing in China in the same era that's being talked about. And I am not expert, but could refer you to some of the names at a later time.
Brian could talk a lot, I think, about
So,
logo in Japanese.
yeah, no, in fact, in the early days of local computer systems, we ended up localizing our versions to, I don't know, it was a dozen different languages. And we didn't realize until Cynthia, Margaret, Artemis, and I were amongst a group co-authoring a history of logo paper, that back in the early 80s, programming languages were all in the English, except for an obscure couple that were in French. And we originally figured that this is something for kids. Kids should be able to interact in their own languages. To try to answer the question directly, I'm not sure we saw that much difference that was based exactly on language. We saw tons of difference based on school cultures. And as you can imagine, school cultures in different parts of the world were quite different.
All right, I think we have time for one more question. We have about 2 minutes left. Anybody else?
I have a question.
Oh, you want to say something? All right, why don't you say something? You'll be the last speaker, okay?
Is that to me?
Yes, Rihanna.
Okay. Yes, it's Rihanna. Hi, Cynthia. Hi, Ryan. I actually have the book here that you just mentioned. So I am an educator and I teach, among other things, creative coding, and recently with Cynthia Turtlestitch. And what I find when I'm working with my students is that I find most of them, their minds to be quite corrupted by traditional schooling methods, and they find it hard to get creative. So I find the concept of creating micro worlds very powerful. And I was wondering if you had some practical tips on how we can create these inviting and nurturing learning environments for our students.
Do you want to answer that first, Cynthia, or should I? I'd say, but it would be kind of cheap, is take a look at turtle art.
I did. And I love it.
Okay.
Well, I mean, but I think that's a kind of question that somebody not you would ask. I am surprised that you generate that question, because it's like about teaching and about letting people know they can be creative, that it's okay to try things and even try things other people have done, but you can make it your own by very small modifications, very big modifications. And that's the power of computing. For me, in a graphical context, where you can see the changes easily.
All right.
And what you as a teacher need to do is unlock that user's interest. You know, they're not that they don't want to do what I want to do, but you'll find something they want to do, and you may not want to do it, but you'll do it to help them. How's that?
All right. Well, thank you, Cynthia. Unfortunately, we're out of time. I appreciate you and Brian and Rihanna and Margaret and all the others, and for giving the talk. It was really interesting. Appreciate coming back and doing a talk focused on the education side. It was really nice. That was part of our theme, computers and education. So everyone, please give her a big hand.
I just would like to thank the organizers for giving us the chance to present this.
Yes, I do too. We had a lot of fun, and I hope that the people that were listening also had fun.
Oh, absolutely. Yes, you're very welcome. All right. Have a good day, everyone.